Hello learners, welcome in the course of wind energy utilization. In this course we are going to have this units. Unit 1 will deal with the wind energy conversion system. Unit 2 will be based on the wind power plant, in which we are going to see the details of the construction of the wind power plant, the various components of the wind power plant. In unit 3 we will be talking about the wind power control strategies. Unit 4 will deal with the power quality issues related to the wind power plant, and finally in unit number 5 we will see the various developments in the wind power plants in India. So, to start with, we will start with the unit number 1, that is the wind energy conversion system. The learning outcomes of the wind energy conversion system unit is, after the completion of this unit, the learners will be able to explain the wind energy conversion system with the help of block diagrams. So, these are the contents of this particular unit. First, we will be having a look on the introduction to the wind energy resources, then characteristics and types of wind, followed by Weibull and Rayleigh's distribution, wind energy available in the wind, and wind energy conversion system with a block diagram, and finally to conclude with this topic we will be dealing with the Bett's coefficient. Let us start with the wind resource. So, before starting this, let us have a look on these two pictures. So, what can you conclude with the two pictures that is in front of you? So, what we can say is that the sun heats up the earth's surface, and hence the air close to it rises up. When this air is the hot air, when this hot air rises up, the cold air sinks at the bottom. Because of this, what is happening is high pressure area and a low pressure area is created, and because of the creation of this high pressure and the low pressure area, there is a movement of air. So, what basically wind is nothing but the air in motion, and when we say the air in motion, this air in motion has power which can even bend the branches of the tree, which you can see in this particular two pictures. In the first picture you can see that the bend is towards the right, and in the second picture you can see that the bend is towards the left. So, the direction of the wind decides where these branches are going to bend. So, when we say already have stated that the air is set in motion by the difference in the temperature and air pressure due to the solar radiation on the earth's surface. Now, since the air has mass, the wind contains kinetic energy, and wind power plant utilizes this energy of the wind to produce the electrical energy. Then what is wind? Wind is the air in motion, and this wind, which is available freely, has the power to bend the branches of the trees even, and this power of the wind is used to turn the wind rotor, and which in turn produces the electricity. Then when we say that what is the reason of the flow of wind, it is nothing but due to the uneven heating of the earth's surface. How the earth's surface gets heated, or what is the reason of the uneven heating of the earth's surface, let us understand with the help of this diagram. So, in this diagram you can see that the sun rays falls on the earth's surface. This sun rays which is falling on the earth's surface, there is a typical distribution of this sun rays on the earth's surface. This sun rays you can see that are short in the tropical region, and it becomes long on the polar regions. So, because of this short and the long rays of the solar radiation, the tropical region gets tropical region of the surface of the earth gets more heat energy as compared to the polar regions. So, when we say that this tropical region gets more heat energy than the polar regions, the air the surface air at the surface of the surface of the earth on the tropical region gets heated up, and this heating up of the surface of the on the surface of the earth, the air becomes hot and or warm. This warm air rises up and ultimately the cold air sinks at the bottom, and because of the sinking of this cold air at the bottom, the pressure region creates, that is the high pressure and the low pressure, and because of this there is a flow of wind from this tropical region towards the polar region. Air is a mixture of gas, solids and liquid particles. Cold air is heavier as it contains more air particles than the warm air, hence it sinks at the bottom of the atmosphere and creates a high pressure area. Warm air on the other hand is lighter and therefore rises up, creating a low pressure region. As the warm air rise up, moving the cold air to sink down, there is a movement of air from high pressure areas to low pressure areas. This movement of the primary cause of air is the uneven heating of earth by solar radiation. By and large, the air is heated directly, but solar radiation is first absorbed by the earth's surface and then it is transferred back to the atmosphere in various forms. As the surface of the earth is not homogeneous, that is land, water, desert and forest, the amount of energy absorbed varies both in space and time. This results in the creation of difference in atmospheric temperature, density and pressure, which in turn creates forces that move air from one place to another. During a year, tropical regions receive more solar energy as compared to the polar regions. There is an exchange of thermal energy across latitudes with wind as the medium of convection. This is because neither the tropical region becomes hotter year on year nor the polar regions become colder year on year. This is only because of high pressure and low pressure regions created due to the warm and cold air respectively. Another important cause of large scale air movement is the rotation of earth, which gives rise to two effects. Let us see these two effects in detail. The first effect is called as the Coriolis effect. So, to understand this Coriolis effect, let us have a look on this diagram. So, in this diagram what you can notice here is that the earth is continuously rotating and the topography of the earth's surface up to an altitude of 100 meter affects the flow of air in various ways. When viewed from the ground, with respect to this diagram, what we can understand is when viewed from the ground, the wind movements in the northern hemisphere appears to bend towards right, and to that of the southern hemisphere deflection is towards the left. So, this apparent behavior of the bending of the wind movements towards right and the left directions respectively is called as the Coriolis effect, which is named after the French scientist Gustave Gaspard Coriolis. So, what we can understand from this particular picture is that the equator receives the most direct rays of sun, and here the air gets heated up and then rises, leaving behind the low pressure areas. The cool air then sinks and moves back to the equator and rest of the air flows towards the poles. Around 30° latitude in both the hemispheres, the Coriolis forces prevents the air from moving much farther. At this latitude, there is a high pressure area as the air begins to sink down again. The Coriolis force is 0 at the equator, which you can see there is no deflection at the equator. This is the reason why the Coriolis force is 0 at the equator. Further, the air movements towards the equator are called the trade winds. These trade winds are characterized by the warm, steady breezes that flow almost continuously throughout the year. The primary cause of air motion, as we have seen, is the uneven heating of the Earth's surface by the solar radiation. These trade winds, that is the westerlies and the easterlies, flow around the world and cause many of the Earth's weather patterns. Westerlies are the steady winds that generally blow between 30° and 60° latitude in both the northern and southern hemispheres. These are the wind that are good for wind power generation. So, as you can see from this picture, the westerlies and easterlies, that are the trade winds, which are visible from this diagram, and easterlies are the low latitude trade winds which are near to the equator, and poles that blow from east to west. Again, these are the trade winds that are steady throughout the year, and hence the variation in the wind speeds in this region is quite less and strong enough for wind power generation. Let us understand the second phenomena or the second type of the winds, that is the geostropic wind. So, when we talk about the geostropic wind, let us understand the geostropic behavior first. Here you can see with the help of this particular picture, it should be 1002 millibar. The pressure gradient force and the Coriolis force, these two forces are responsible for the geostropic wind. Let us understand how. So, the gravity pulls the air towards the earth surface, and close to this earth surface the wind is influenced by the friction which is against the surface. This friction decreases as we move away from the surface of the earth. With the increase in height from the surface of the earth, this friction gradually decreases, and at a certain height this fraction becomes almost negligible. So, the geostropic wind is a special case in which the rising air reaches a condition of balance of two forces, that is pressure gradient force and the Coriolis force, and in such a condition the wind flow becomes parallel to an isobar, and this undisturbed wind is called as the geostropic wind. Let us understand the characteristics of the geostropic wind. So, the geostropic wind is generally found at an altitude of 1000 meter above the ground level, and which are not very much influenced by the surface of the earth. The distance from the ground to the geostropic wind varies and depends on the weather conditions and surface roughness as well. High friction increases the height of the geostropic wind. Then The Earth's surface is marked with the trees, buildings, lakes, seas, hills, and valleys, all of which also influence the wind's direction and speed. Example, where the warm land and cool sea meet, difference in temperature creates thermal effects which causes the local sea breezes. The strength of the geostrophic wind is affected by the Coriolis force, and finally the direction of the geostrophic wind is determined by the balance created by the pressure gradient force. So, we will summarize today's lecture. Today we have started with the first unit, that is the wind energy conversion system, but before moving to the wind energy conversion system, we have understood what exactly the wind is. We have come to know that wind is nothing but the air in motion, and how this wind is formed and how the movement of air is formed due to the uneven heating of the earth's surface. We have also understood the Coriolis effect today, which is named after the French scientist Gustave Gaspard Coriolis, and also we have seen today the characteristics of the geostrophic wind. So, we will end here today. Tomorrow we will start with the next topic, that is the Rayleigh and the Weibull distribution. Thank you.